In this session, we will try to know about the erosional landforms as produced by the underground water. Let us know whether the concept of cycle of erosion is applicable to the karst topography. What are the typical landforms associated with each stage? The main objectives of this lesson are to know about the process involved in the erosional activity in the karst landscape, to know how various erosional landforms are produced in the karst region, to study about the landscape development in the various stages of karst cycle of erosion. The erosional work of the underground water is not much undertaken through the mechanism of corrosion or aberration and hydraulic action. The corrosion and hydraulic action are very insignificant and not very effective because of the exceedingly slow movement of the underground water. The corrosion or chemical erosion in the form of solution activity is the only effective method of erosion of carbonate rocks by surface and subsurface underground water. When the rainwater is mixed with the atmospheric carbon dioxide, it forms weak carbonic acid which can dissolve the rock like limestone and thus produces a variety of erosional or solutional landforms. These erosional landforms are 1. 𝗧𝗧𝗧𝗧, 2. Sinkholes, 3. Swallow holes, 4. Dolines, 5. Uvala's, 6. 𝗿𝗁𝗺, 7th karst window, 8. Sinking creeks, 9th underground cave, 10th natural bridge, 11. ponors and 12th blind valley, and 13th terra rossa and 14 humps. Generally, swallow holes, dolines, uvala's and 𝗿𝗁𝗺s etc. are considered as sinkholes related or associated sequential features. 𝗧𝗧𝗧𝗧 are generally formed due to the corrosion of limestone along the joints when limestones are well exposed at the surface. The permeability of limestone allows the water to percolate very easily through the joints. Joints soon becomes widened and deepened, which results in the surface becoming very wide with irregular gullies called as grades. The separated blocks of limestone surface along the joints are called as clines. The term 𝗧𝗧𝗧𝗧 is a French term for the fretted and fluted or highly irregular or rugged surface of the limestone marked by small rills and gullies. Minor ridges or pinnacles and deep clefts. Sinkholes. By far the most common and widespread topographic form in the karst terrain is the sinkhole. In major karst areas, sinkholes are found in very large number. Hundreds of sinkholes are found in the karst areas of southern Indiana and Kentucky region of USA. Chemically active rainwater charged with atmospheric carbon dioxide dissolves limestone and other carbonate rocks along their joints and thus forms sinkholes. Sinkholes are the small cylindrical opening on the surface of the limestone through which the surface water turns into the form of underground water. The depth of the sinkholes ranges from few centimeters to few meters. The rain drains through these sinkholes and finds its way underground route through the sinkholes. Swallow holes. Enlarged form of sinkholes is called as swallow holes. Gradual enlargement of the sinkholes due to the continuous dissolution of the limestone results in the formation of large holes which are called as swallow holes. Swallow hole or a swallet is the point at which the surface stream disappears under the ground in the karst terrain. Dolines. Some swallow holes are further enlarged and continuous solution into larger depressions called as dolines. Dolines are the funnel-shaped openings on the surface of the limestone region. The term doline is a Serbian term for dolinas, comes from the karst region of Yugoslavia, which is used for the solution sinks. 𝗂𝗧𝗧. 𝗂𝗧𝗧 are the very large tongue-shaped elongated depressions formed on the surface of the limestone region. They are formed due to the coalescence of smaller or several dolines. It is a Bosnian term applied to large depression resulting from the collapse of the extensive roof section over the underground water courses. Sometimes compound sinkholes are also called as 𝗂𝗧𝗧. Polges. Polges are most extensive depressions that develops on the surface of karst region due to the merging of adjacent 𝗂𝗧𝗧s. They are characterized by vertical side walls and flat floors. Polges are in fact closed basins, elliptical in shape. A polge may somewhat resemble an 𝗂𝗧𝗧, but it differs from it in origin and extent. It is formed due to the solutional modification of down-faulted and down-folded limestone blocks. A typical example is a seizable feature covering many square kilometers, whereas 𝗂𝗧𝗧 commonly covers only few acres. Karst window. It is the unroofed portion of the underground stream course through which we may see the stream which flows out of the cavern. Karst window is a special type of collapsed sinkhole. The term is applied to an unroofed portion of an underground stream course through which it may be seen a stream which flows out of the cavern. The river flowing in the cavern can be seen through the karst window. Karst window is formed due to the collapse of the upper surface of the sinkhole or dolines. These windows enable the investigators to observe and trace the continuity of the surface stream into the form of the subsurface stream or drainage and other features formed on the surface. Sinking creeks. The surface of the karst plain looks like a sieve because of the development of closely spaced numerous sinkholes. These sinkholes act as funnels because surface water disappears into the underground through these holes. When surface water disappears through the numerous sinkholes located in a line, the resultant feature is called as sinking creek. The point through which water goes downward is called as a sink. The water of the short rivers disappears through the sink, while that of large streams disappears through many sinks. Underground cave or caverns. Caves or caverns are one of the most important characteristic feature of the underground water in the limestone regions. Caves or caverns are voids or hollows of large dimension below the surface. Caves are the most significant landforms produced by corrosion or solution activity. Caves vary in size ranging from small to very large size. Large caves are found in the regions of massive and thickly bedded limestone. When surface streams disappear at the sinkholes and take the underground courses, they dissolve the limestone to form their passage. These passages are enlarged due to the corrosion of limestone. Underground caves are also called as subterranean caves or simply limestone caves. Carlsbad and Mammoth caves in New Mexico of the USA are the examples of very extensive caves. Natural bridge. Natural bridge are formed either due to the collapse of the roof of the cave or due to the disappearance of the surface streams as subterranean sea. When a large section of the cave roof falls and middle portion is left hanging, a natural bridge may be formed. The roof of the cave is eroded until a small part of the roof was left as natural bridge. Ponors. Ponors are the vertical or inclined passage that connects the caves with the swallow holes. Ponors are formed due to the downward extension of the sinkholes. They are called as ponors in Serbia and avens in France. Ponors are deep shaft like hole in the limestone terrain leading down into the underground cave. Blind valley. Blind valley is the valley of the surface stream which disappears in limestone region through a swallow hole or a sinkhole. In other words, valley is called as blind valley where the flow of water terminates at a swallow hole and valley looks like a dry valley. For example, the blind valley of 𝗧𝗦𝗔𝗧 𝗬𝗏 river in the former Yugoslavia is 40 km long. According to some scholars, blind valleys are developed on the Uvala floors. Terra rossa. Terra rossa is the residual red clay soil that develops on the surface of the limestone region as well as extending down in the joints. When rainwater dissolves part of surface rocks and enters subsurface, particles of red clay soil is deposited on the surface of the joints. Terra rossa resembles lateritic soil. It may not be developed at the steep slopes but can be seen in areas which are either flat or with gentle slope. The thickness of terra rossa varies from few feet to many and sometimes may cover the entire surface. Terra rossa is thus formed due to the surface and near surface solution activity by the descending groundwater, which usually leaves the residue of a red clay soil covering the surface and extending down into open joints. Humps. Humps are the residual hills analogous to the monadnocks. They are the erosional remnants after the karst landscape have fully developed. These hills are called as Haystack Hills or Pepino Hills in Puerto Rico and Mogotes in Cuba. In karst areas of Yugoslavia, such residual hills, which are the erosional remnants in the karst region, are called as humps. They are seen when the region reaches the old stage in the cycle of erosion. The concept of cycle of erosion can also be applied to karst topography. Davis in 1930 regarded karst cycle of erosion as a special phase of the normal cycle of erosion, characterized by the development of surface drainage, disappearance of the surface drainage, and underground and reappearance of the subterranean drainage as the surface drainage. The karst cycle of erosion is simpler than other geomorphic cycles because the uniformity of the structure, that is limestones, and dominance of monoprocess, that is solution activity. Wijik in 1918, on the basis of the study of karst topography of Yugoslavia, recognized 4 stages of karst cycle as youthful stage, maturity stage, late maturity stage, and lastly the old stage. The characteristic features of the different stages of karst cycle of erosion are summarized as: 1. The youthful stage. The karst cycle of erosion starts with the initiation of the surface drainage in the region of thickly bedded limestone. The limestones are directly exposed at the surface. The rainwater mixed with the atmospheric carbon dioxide now reacts with the limestone along the joint planes and thus forms sinkholes, swallow holes through the mechanism of solution process. These sinkholes gradually increase in number and enlarge due to the continuous solution of limestone. The ground surface is characterized by rough terrain due to the development of 𝗧𝗧𝗧 because of the dissolution of limestone along the joints. With the enlargement of sinkholes and swallow holes into dolines, surface drainage starts disappearing underground through different sinks and blind valleys. The underground drainage initiates the formation of caves and caverns through the underground solution and aberration. The characteristic geomorphic features of this stage are sinkholes, swallow holes, dolines, 𝗧𝗧𝗧𝗧 and blind valleys, and also sinking caves, caverns of smaller dimension. Thus, the youthful stage is characterized by slow sinking of surface drainage and progressive development of underground drainage. Maturity stage. The initiation of early maturity is heralded by the disappearance of the surface drainage underground. Thus, the ground surface is characterized by dry, waterless condition. The surface drainage disappears underground through dolines and blind valleys. These numerous sinking creeks are formed. The processes of underground solution and aberration are augmented because of the increased volume of water due to maximum development of subterranean drainage. Increased solution of carbonate rocks results in the gradual enlargement of caves and passages. The covering roofs of the caves and the caverns undergo the process of thinning because of all-round enlargement of the caves. The thinning of the cave roofs causes their collapse and giving birth to 𝗂𝗧𝗧𝗧𝗏 pole jays, natural beaches and cast windows. The residual uplands with highly pitted surface between 𝗂𝗧𝗧𝗏s become ridges. The late maturity is characterized by the destruction of most of the solutional landforms. In the maturity stage, there is maximum transfer of surface water into the form of underground water. There is extensive cavern development. This is the stage when maximum karst development takes place. Late maturity stage. In the late maturity stage, the features of the karst landscape or topography starts declining. Isolated residual hills in the form of humps dominate the surface. Old stage. In the old stage, the cave roofs are totally collapsed and ridges and pitted surface between 𝗂𝗧𝗧𝗏s are considerably narrowed and reduced in height. The residuals of carbonate rocks project slightly above the ground. They are called as humps. Most of the surface is levelled and thus resembles a peneplain of the normal cycle of erosion. The subterranean drainage again appears on the ground surface, which is called as resurgence. Nearly all the karst valleys, solution holes and sinking creeks are eliminated. The second cycle of erosion may start with the fresh upliftment of the karst plain. The old stage is initiated with the beginning of the return of the surface drainage. Humps are the most diagnostic feature of the old stage or the ultimate stage of the karst cycle of erosion. The erosional features in the karst or limestone region are mostly produced by the corrosion or solution activity. The transfer of surface water into the form of underground water is mostly through the joints present in the limestone rocks. The solution activity which is concentrated in the joints naturally results into the formation of sinkholes. Subsequent solution activity along the sinkholes produces various features such as swallow holes, dolines, uvalas, polges, etc. The other solutional feature includes sinking creeks, natural bridges, blind valleys, etc. The underground cave is the most typical and characteristic feature of the karst landscape produced by the solutional activity. The red clay soil that develops over the surface of limestone region is called as terra rossa. The youthful stage in the karst cycle of erosion is characterized by the disappearance of the surface drainage into the form of underground water. The typical features produced in this stage includes sinkholes, uvalas, lapis, caverns or caves, etc. The maturity stage is characterized by the disappearance of surface drainage into the form of underground drainage. The old stage is characterized by the collapse of the roof of the underground cave. Residual hills in the form of humps, appearance or resurgence of the surface drainage.